All right, very good morning, everybody. Hope you had good learnings today from the keynote session and got good break in between. Quick raise of hands for people new to GraphQL. All right, I see a couple of hands. How about people running GraphQL APIs in production? Oh, wow. That's a lot. All right. So welcome, everybody, to today's talk on 200 is not OK, strategies for tracing partial responses with GraphQL observability. Irrespective of where you are in your GraphQL journey, we hope that today's talk will be of great value to you if you care about your customers. So joining with me today is my colleague, Rama Palaniappan. Quick intro.
Hi, I'm a principal engineer at Intuit's API platform management team.
And myself, I'm software engineering manager at Intuit. I work along with Rama on API platform team, focused on GraphQL API platform team. We are building the platform at scale for serving all the GraphQL API traffic at Intuit. And we are running GraphQL Federation, have been in production for 2 years, and have served billions of requests during the tax season. So before we dive deep into the topics today, just want to give a highlight of the agenda today. So for a moment, just think about your software is using REST APIs. In that case, the general norm is that for observability, you will think about HTTP status response codes. So if your API is responding with 500 or greater than 500 response code, you know that there is a server error. Whereas in case your APIs return HTTP 200, you can trust that your clients have received the data they requested for. However, the same is not true in case of GraphQL APIs. If you continue to rely on 5xx errors to serve as to consider as the server errors, you are at the risk of undercounting your failures in the software system. Because as the topic for today's talk says, 200 is not OK, or rather 200 is not always OK in GraphQL APIs. So in today's talk, we are going to talk about the nuances of GraphQL API observability. And we are going to showcase how Intuit is capturing the observability using metrics, logs, and traces. So let's talk about observability a bit. To ensure the availability and reliability of any software, you need the real-time visibility into two things: your system health and how it behaves. And you need to monitor different components, including the infrastructure, the application, how does the data flow. And that you need to basically monitor each of these to understand how they interact with each other. In simple words, we all need observability of our software. Now, for observability, we need to collect data, and we need to analyze data from different sources, including the metrics, logs, and traces, which we commonly refer as the 3 pillars of observability. So just very basic, metrics are quantitative measurement of your system performance. For example, it's your latency, the error rates. Logs are the chronological record of the events generated by your software systems. And traces are used to segment and trace a request as it flows through the software system. So at Intuit, one of our core values is customer obsession, which teaches us that our topmost priority is always customers, and we need to keep them happy. Now, this is possible only when our software systems are operational and those are accessible. And the other thing is that the customers are able to perform the intended action. So technically speaking, we need the high uptime of our softwares, and we need the low MTD and MTTR values. For those of you who are not aware of MTD, MTTR, these are the key performance indicators during the incident management. MTD stands for mean time to detect. So that's the time from beginning of your incident till the issue is detected. And MTTR, which is referred as the mean time to recover or mean time to repair, is the time it takes for to fix a software after the failures are being observed. So at Intuit, we do measure the health of services using some key metrics, which we refer as the golden signals. On the slides, I've put up some key metrics, which are system calculated metrics. The request tells us what is the load being put on the software system. The error tells what is the rate of the requests which are failing. The latency tells us how much time a request takes to process. And availability tells us what is the success rate for the API calls. So let's take a close look at one of the key metric, which is availability. So we use a very standard formula for calculating the availability of our software system. It's total time minus the downtime divided by total time into 100. The total time refers to whatever time the software is accessible, whereas the downtime is when the software is not able to serve the traffic. So when we apply the same formula to calculate the API availability, it gets converted into total request minus number of 5x6 errors in the system divided by total request into 100. Now, if we take this formula and we apply for REST APIs, it is pretty straightforward. We can have the API availability for REST APIs. Now, what about the GraphQL APIs? The question is, can you apply this formula as is for GraphQL APIs to calculate its availability? With that question, I'll hand it over to my colleague, Ram.
Okay. So as Aditi said, if you get a 200 or a 2xx from a REST API, you could safely consider that as a successful response the client expected it to be. And you could count them as in the success bucket or the available bucket. But in GraphQL, there are cases where you would get a 200 or a 2xx response, but it may still have a server error in it. So those are the cases that we would want to make sure we are not undercounting our availability number metric specifically if we just see the 200. Okay. So to explain that, I'll just have here like the client on the left side is making a call to a GraphQL server. Assume this GraphQL server to service this request has to depend on two different dependent systems. So these dependent systems could be your persistent store, eventing system, or another API itself. So assume one of the system, like this dependent system 1 returns a successful response back to the GraphQL server, but the dependent system 2 is unavailable or not reachable, so you're having some sort of a server error from there. So now at the GraphQL server, it has a partial response because the dependent system gave something, so it has some response out there, but it doesn't have a response from dependent system 2. So what should the GraphQL server set this HTTP status to? So as per the GraphQL HTTP specification, if you look up at it, as long as you have a data section in the GraphQL response, you should set it to 2xx, generally 200, but there are certain other ways. You could also set it like 207, 247, and things like that, but it's a 2xx stuff. So with that, we also agree that it should be 2xx because there is some sort of partial response in there, so it should be 2xx. But for observability need, we need to make sure this error is captured. So this is the partial response problem. Okay. And if you at Intuit, we use a federated GraphQL system. So the partial response gets more visible in this kind of a system. Like the client makes a call to the federated GraphQL gateway here, and that particular request, if it's going to go to 2 different subgraphs, as mentioned here, and these subgraphs will have its own dependent systems. So in this case, if any one of the 4 boxes on the right side is unavailable or giving a server error, okay, the GraphQL server is up and running, and the client has sent a proper, well-formed GraphQL request. So its GraphQL gateway is going to give 200 HTTP status response always. So what we are seeing is, if it is just one GraphQL server, the chances of partial responses may be low, but in this case, the chances of a partial response is high because you have a very distributed system, and any system in your thing downstream there could go down, and you would you have a potential of undercounting your availability numbers if you just depend on HTTP status for that. Okay. So what do we do? So the ideal way is, if you see, we have to also see the error in the response. In both the cases, the error in the GraphQL response would have captured the actual error. And there are cases where the error could be a client error as well. Like assume you are looking for a resource by ID and that ID doesn't exist. So that could be basically considered as a client error. The client asks for some ID that's not available, but that may also be in the error section. So the moment you see an error, it doesn't mean that it is a server error. There could be some client error. Ideally speaking, you should have a proper schema way of representing the client error so that they could do it, like it should be a union of a result and things like that. But most of the GraphQL APIs that we have seen, they still send out client error as well in the error section. So first thing is we have to identify whether it is a client error or not. Then we need to send out, those server errors to our observability systems. And the observability system should consider both the HTTP status and this signal that it has to verify whether the request is successful or not. So that's what we are going to do. Let's see a demo of that. It was working faster before. Oops. Okay. So here I'm using a federated query. So the test show and title field are from subgraph 1, and fields actors and names are from another subgraph 2. So I have explicitly made sure the subgraph 2 is giving a server error. So that's the demo that I'm going to show. So when I execute this on an API Explorer, maybe I'll just make it a little bigger. So I'm getting a data fetching exception here. So what happens is the client makes a call, it goes to a API gateway and then a GraphQL gateway, federated gateway, then to subgraph 1, and then finally to subgraph 2. So in subgraph 2, I'm explicitly making a server error. So that's what we saw in the thing before. So to check the observability stuff, what I'm doing is I'm just generating some traffic out here. So if you see the status is 200, but if I go look into the subgraph 2's availability number, it is at 0% because I'm just giving a server error always. So the way this is identified is, as I told, we are sending out a signal saying that if there is a server error, we do that. So in this case, what we're doing is, this is a GraphQL Java based one. So we are using the GraphQL Java's instrumentation to classify whether the error is a client error or not. And basically, by default, we assume it's a server error, except for those few things. So we have GraphQL Java and DGS. So whatever the default client errors, we just identify them. Everything else is a server error. So that's how we send it out. So the observability tools would say that if it is a 200 and I don't see a server error, a signal for GraphQL API, only then consider it as successful. If you see either 5xx or you have a server error signal in, it consider that as a failure. So that's how we would do that. So back to Aditi for the logging side. Pause. Oh, where is he? Oh, it's over here. Okay. I think you have to look there.
All right, some glitches always happen, isn't it? Okay, so talking about logging, it's useful for troubleshooting and debugging always. You can use it as audit trail as well. Very easy to print everything in your application, but refrain from doing that because it will make the troubleshooting and debugging even harder. And in fact, in some services, you might also see impact on the performance of your services. So refrain from printing too much, use proper log levels, info debug error. And in case of GraphQL, consider printing the errors which are contained in the response body, because even after you do the code instrumentation, you'll need more details about the errors from the GraphQL which are contained in the response body. So that's just a recommendation. So at Intuit, we, as Rama said, we are using the GraphQL Federation. So we log at every layer of GraphQL Federation optimally. And we are using a unique identifier for every request, which we refer as the transaction ID or the TXID. It is added as a header, and it's the request header, and it's also been returned as the response header to the client. And it's been propagated across all layers. So the benefit of using this unique identifier for every request is that we are able to correlate the logs at each layer using the unique identifier. So we have built our monitoring dashboards based on this unique identifier. Let's see a quick demo how we are using the dashboards to drive the low MTTD and MTTR values. I don't know how this is going to work. Okay. So just want to highlight the GraphQL Federation architecture a little bit more. So the traffic from the clients on the internet side, they come through the Intuit API Gateway. At API Gateway, we apply the basic authentication authorization, and we apply the throttling plans. And the API Gateway forwards the traffic to the backend route if it is an authenticated request. Next, each of the green boxes that you see here over the slide are the Kubernetes namespaces. And these services, in most cases, are running on different Kubernetes cluster. So for cross-cluster communication, we use Service Mesh Istio Proxy, which we run as a side container for each of our applications. From API Gateway, the request is forwarded to the GraphQL orchestrator, which is, we also refer to it as the router. And it is basically a federated GraphQL gateway which fans out the request to the backend subgraph services depending upon the incoming query. Right, so here's a view of a debugging dashboard that we have, we usually use for identifying the errors. The input to this dashboard is the TXID, which is the unique identifier I talked about earlier. So this TXID is returned to the client as the response header. We just grab it, and for any field request, add it as an input to the dashboard. This dashboard highlights from the logs at various layers key field values. So as we can see at the it does display key values from the API gateway logs, then the router logs, and the service mesh table. Especially from the service mesh table, we are able to capture how the request does flow from the API gateway to the GraphQL orchestrator and the backend subgraph services. And we do capture key metrics from the logs, like the response time, the status codes, etc. So in this particular case, the error message which is displayed here is showing that there is some exception at the router layer which happened for a request which returned HTTP status code 200, and the inner error code contained in the GraphQL response body is saying that there's an exception while fetching the data, a particular type called as actors. So from the logs at the router layer, we are able to confirm that there is a problem with the backend subgraph service, and the router layer logs also logs the actual client query which was received from the client. Now, down below in the service mesh table, we are able to see that the request was propagated from the orchestrator to two backend subgraph services. In this case, the exception which was shown in the demo, that was for a particular type called as actors, which belong to one of the subgraph. So we get a good idea that we need to take a look at the logs of that particular subgraph to figure out what was going wrong with that particular subgraph. So that helps us identify the issues pretty quickly and drive the low values for MTD, MTTR. Over to you, Ram.
Yeah. So the next pillar of observability is the traces. Okay, so the distributed tracing is a way for you to observe how a request goes through multiple components in a microservices architecture. So we use OpenTelemetry based distributed tracing here, and the benefits of distributed tracing is you get end-to-end tracing. If you wanted, you could do it from your front end all the way to your database call. You could be able to figure out like where all it went, and you could send context as part of this tracing so that you could stitch it later at a later point. We'll just figure out, like, especially the service call graph or the trace waterfall is actually stitched based on the context that is being propagated during the tracing. And this will primarily help in identifying which component in your microservices has a problem, if there is one. That's the first benefit of it. And the other part is it'll also help you to reduce your MTTR, that is the time to recover. So those are the higher advantage of distributed tracing. So I'm not going to go deep into the OpenTelemetry parts out there. So basically from a high level, what we are doing here is, and at an application layer or any software layer, you are creating a scope, basically a name for a particular operation that you're trying to do, and when is that operation started and when it ended. Okay, so this scope and the time, together with a lot of contextual data, is what we are sending it out to a tracing backend. Okay, so I'm just ignoring the exporter, route, agent, collector, and all of those things. So we're just sending it to a tracing backend. So similarly, a lot of these other applications that are part of the microservices architecture will also send the same kind of things in there. So at the tracing pipeline layer, what it does is it stitches across all these spans that it got together with the contextual information. As Aditi mentioned, for the log, we send out something called transaction ID. So for this one, we also have something called trace ID, and together with it, like a lot of other attributes that will be sent. So it will stitch together, and you can, when a user searches for a specific trace ID, they could check the waterfall part as well. Or if you want to do a little bit deeper, a bigger analysis, an aggregated analysis, you could say that, okay, for this particular scope, how is it doing? Like, what is the minimum time? What's the maximum time? If you have any other attributes that are associated with that scope, you could also look into all of those things. Let's see in a demo. Hopefully, this thing works right now. Oh. What happened? Something with my demos. Okay, yeah. So it's the same thing, and I'm going to use a particular transaction that we saw in both the metrics demo as well as in the logging demo. We'll just see how it goes through, and the intention of this tracing is that we just want to trace a request and all the way from here, API gateway, tier, and both the subgraphs. That's our goal. So in the logs itself, we are also displaying the trace ID. I'm just picking one of them from there. And I'm going into the tracing backend that we have and entering the trace ID here. And you could set when was this trace, the time range, and then you could run it. Okay, so this, I hope it clears a bit. Okay, I assume it comes up better. So basically what we are seeing here is, we are seeing this is the API gateway, this is the orchestrator or the router layer, and we have two subgraphs that are being called. And you could have as much scope as you want, and you could also send out like how much data do you want to send your traces to. So you could also sample it. You could do head sampling or a tail sampling depending on what kind of stuff you want. You could do it. So with basically from metrics, traces, and logs, you can reduce your MTTD and MTTR. And in addition to it, these are not only for MTTD and MTTR or only for the incident management. You could use these data to understand your system better and also understand your user behavior better. You could use all of those things. So the last one is, let me set things right. Like I'll go unset the explicit error that I gave in the subgraph 2 and generate a load again and see whether we are seeing a high availability again back up or not. Okay, while this is there, maybe that's the last part of it. Okay, yeah, here it is. So I'm just syncing back to a proper version in Argo CD, and it should be up in a while. Yeah, now we have proper pods working for subgraph 2. I'm running the same query again. This should return a proper value that'll be without any server error. I think I shouldn't have depended on the Wi-Fi for these videos. I should have copied it locally. So that's a learning point for me. Okay. Anyhow, while this is not that great, like we'll get to see it while it loads. But if you have any questions for us, like 3 more minutes is what we have. So if you have, yeah, go. Yeah.
Okay. So you mentioned 2 levels. So 2 things: logging and OpenTelemetry integration. Well, what it seems like our company uses OpenTelemetry integration, but it seems like there is a lot of like crossover between like the information shown between logging and the information shown between OpenTelemetry integration from what I see up there, which is the trace stack, errors, and which subgraphs like the.
Yeah, ideally you don't want to put in a lot of things in the log. If you can do things without the log, that's great. You could do it through metrics and the traces. And both metrics and traces would most often would be sampled. You would not have 100% of your traffic going through those. For metrics, you may still send it, but for traces, you will still have a sampling in there. But if you don't want to do through logging is far more expensive than the other 2 things. So all of these are expensive. So you have to figure out a right balance for your system.
Okay, sorry, one last question. For transaction ID, we actually use trace ID as like the efficient lookup. I was wondering, like, do you have a trace ID and transaction ID?
Right now we have 2 different things for us. Like, but if you are comfortable using the same ID, that's good. As long as you need to have a unique ID that goes across all the layers, that's the important thing there.
Okay, awesome.
Yeah, you have.
I actually had a follow-up question regarding that.
Uh-huh.
What do you recommend regarding transaction IDs? Should they be unique? If they are unique, what the size? Where is that stored? Or does it not matter? You just put a GUI ID and it doesn't come.
It all depends on how the use cases. At Intuit, we have 2 sets of use cases. So there's like if the client doesn't provide a transaction ID, and a unique ID is automatically generated for you. So that's in that way, every request will have a unique transaction ID, though the same ID would be propagated all the way down to all the components it faces. But there are cases where the client wants to override it, saying that, okay, I want to do like 3 calls, and I want to group all of them in one transaction ID. So the client may provide a transaction ID, but there will be 3 different HTTP calls, and it would go there. So it would be a little bit harder for them to understand it, because you'll have you have to figure out like which API call came through. Like it all depends on your use case.
When you say unique, right, it implies that there's a store that's actually managing
You just give a good ID.
So it doesn't matter.
Yeah.
Are your use cases for GraphQL mainly queries and mutations, or is there also subscription that?
Right now, we use only for queries and mutations.
Okay, all right. So a follow-up question. So for tracing, it's a sample trace, correct?
Yeah.
It's a sample trace.
Yeah.
I mean, how do you set the right level of kind of sampling to kind of make sense, right? Because MTTR for logs and metrics make a lot of sense, but for use cases where there's a client complaint and
You don't use
sample
it.
trace, what do you do? What do you handle?
So I would say that's also depending on your systems. Like, how do you identify a particular user? Like, there are different ways of sampling as well in there. So I would say you could start with 100% for a shorter period and figure out like what kind of stuff that you're looking at it. Like, who are the, like you may say that, okay, for me, the users from this region is far more important, so I would want to sample them higher than the other regions, or this client is important than other client. Like, you would have other options in sampling as well. I would say start with 100% for a shorter period and then figure out like what is your, whether that captures it and where all things you can reduce it. Like, if it's all similar, you don't need to really care about it. Like, you just take some percentage of it and assume everyone is covered in there. But if there are usage patterns that are different, then you need to cater to that as well.
I think for that, you need to also consider the performance.
Yeah.
Because usually if you are emitting more traces, your performance decreases. So
Yeah.
you have to find the balance.
Yeah, and one last question. These trace IDs, are they initiated in the API gateway, or do you actually ask your customers to use hotel libraries and actually generate so you can trace?
It's the same way as the transaction ID. So we would generate, the API gateway is the one that generates, and every other systems that follows honors the same trace ID. But you could also override it. Like, if you can write it to say that, okay, if you trust your clients to write your own trace ID, you could also do that.
But today it's actually happening in the API.
API gateway, yeah,
First
first point of entry.
Awesome.
I think it's time for us.